Hi, this video is on wheels and axles and on wedges. This continues our discussion on simple machines and their ideal mechanical advantage. Wheel and axle, you're probably somewhat familiar with. Many things have wheels. You've maybe just never thought, what is the axle? In this diagram, the axle is this piece. If you're thinking about a wheel and axle on your car, the axle is the part that attaches the wheel to the car. Without it, the wheel is no good. But it does not have to be a traditional wheel and axle. A circular doorknob would also be a wheel and axle. This outer part, the wheel, would be the knob, and it would just not have this piece here. If you were to take apart that doorknob, there would be a piece on the inside, which goes to the knob on the other side, and it is connected that way to the door. With the wheel and axle, the larger handle makes it much easier to turn, or the larger wheel, like if you're using a doorknob, makes it easier to turn. The axle. If you've ever had a broken doorknob where this part comes off and you're left with just the peg, it's much more difficult to turn. And so it allows your turning, you can turn it with much less force, again, just like with any other machine. Wheels can also change the speed at which something turns, very similar to what I talked with on gears, that this smaller one would be turning a lot faster than the larger wheel would. Because of the difference in circumference. So if you needed to change the speed at which something turns, it would also be able to do that. When we talk mechanical advantage, it is the radius of the wheel, and if you remember, the radius is halfway to the edge, divided by the radius of the axle. How do I know which one's the wheel and which one's the axle? The wheel is always the larger one, the axle is always the smaller one. So if we look at mechanical advantage, again, and this is again how I'm abbreviating. RW is radius of the wheel, RA is radius of the axle. And if you like the triangle, I'll start again with the triangle. On this one, the radius of the wheel would be at the top, radius of the axle, and the IMA are the other corners on the bottom. This one, the first example, is just asking for mechanical advantage. So when you just have mechanical advantage, you don't necessarily need the triangle. We can come back to that for the next example. If the wheel radius is 90, so the radius of the wheel is 90 centimeters, and the axle has a radius of 15, radius of the axle, what is the mechanical advantage? The radius of the wheel is 90 centimeters. The radius of the axle is 15 centimeters. So to get the answer, 90 divided by 15, which is 6. And again, as with the other examples, centimeters is going to disappear, so the mechanical advantage is just 6. There is no label because it simply is telling you how many times your force is multiplied. On this example, if a wheel has a radius of 0.75 meters, so this is the radius of the wheel, and a mechanical advantage of 6, IMA, what is the axle radius? And again, if I like the triangle, radius of the wheel, IMA, radius of the axle. You can either use the rearrange formula, which on this case would be the radius of the axle. Again, all I'm doing is covering up. Radius of the axle would be the radius of the wheel divided by the IMA. 0.75 meters over 6. Gives you 0.125 meters. That is using the rearranged equation. If you are one of my students that does not enjoy the triangle and you'd rather use the original equation, I'm going to just erase what I just did out of here. This one would be set up that your IMA is 6, so I would have 6 equals the radius of the wheel, 0.75 meters, over the radius of the axle. First step is to multiply both sides. I'm going to use a different color there. That green does not show up very well. multiply both sides by the radius of the axle. So if I rewrite this, I have the radius of the axle times 6 equals 0.75 meters. To solve this, divide each side by 6. And you would get the radius of the axle is 0.125 meters. So either way that you do it, as long as you solve it correctly, you will get 0.125 meters as the radius of the axle. A wedge. A wedge is a ramp or an inclined plane that moves and forces things apart. So wedges are mostly used for cutting or for separating. In this example, you have like a piece that would be, like you can imagine this to have an axe handle on it. So a wedge could be the cutting part of an axe. It could be the cutting part of a scissors. It is a knife blade. Many would say that a doorstop is also a wedge. And so all of those things that are used for cutting, separating, or dividing would be things that are used as wedges. The ideal mechanical advantage of a wedge is the length divided by the thickness. In this case, if I go in a little bit bigger so you can see, the length is going to be from here to here. And the thickness is going to be this distance right here. So if I'm going to calculate the mechanical advantage of a wedge, if a wedge has a length of 27 centimeters and a thickness of 8 centimeters, what is the mechanical advantage? Now, for some of you, you're probably getting tired of me showing you these examples. They are, for a lot of these things with the simple machines, you are simply just using a new equation, but doing the exact same thing you were before. They're very repetitious. Probably the most helpful thing that is coming out of all of these is if you do like the rearranging of the equations by using the triangle, that you can get those from all of these notes as well. So for this example, you would have 27 divided by 8, and you would get an ideal mechanical advantage of 3.375. Again, with no label because centimeters cancels out. What about the length of a wedge? I see that this is a thickness of 2 centimeters and an IMA of 7.5. If I use the original equation, I have 7.5 equals length over 2 centimeters, which means I would then multiply both sides by 2 centimeters. These would disappear, and I would have a length of 15 centimeters. If you prefer to use the triangle, let me get my old stuff out of here. The triangle for a wedge, length on the top, IMA, and thickness in the bottom. So if you cover up L, you would see that length is equal to IMA times T, which would be 7.5 times 2 centimeters, which, again, 15 centimeters for the length. And that concludes our example on wedges and wheels.